Hello, this is Jack Jackson, and we're back with our third playlist, our third part of college geometry. This is week 3 in my college geometry class. And in this video, we're going to be introducing the concepts of distance and between. And let's take a look at some notes here. And this video, some of the things that we're going to be doing is talking a little bit about the idea of distance and order. We'll review real quickly Hilbert's postulates of order and talk about what they mean. We'll talk a little bit informally about measurement of distance first. Then we'll talk about introducing measuring distance, line segments, and circles more formally. And we're going to introduce in this playlist also 4 infinite geometries: Euclidean geometry, taxicab geometry, spherical geometry, and hyperbolic geometry, and talk about what points and lines, rays, line segments, and so forth look like in those different geometries, and also how we measure distance. So let's just remind you that although the material for my course is all connected and it is cumulative, each week you should notice a theme for the new material, or each playlist in YouTube. I put the title of it in the notes for the week. So during the last 2 weeks, or last 2 units, last 2 parts, we have read a little of the history of geometry and its central role in mathematics, and have studied the idea of a geometry, elements of an axiomatic system, basics of proof writing, and sets of postulates. We considered some finite incidence geometries as a way of looking at proofs and building models for very small finite geometries. We have introduced the first 9 postulates, some definitions, and the first 5 propositions from our study of unified geometry. And these postulates, definitions, and propositions all only concern themselves with basic incidence relations, basically subset and element relationships. So this week, in this unit, we're going to be introducing the concepts of order, between, measurement, and distance to our study of unified geometry. Now, in a pure synthetic approach to geometry, in other words, for example, following Hilbert's development, the term between is taken as an undefined term. We certainly have some intuitive notion of the meaning of between in Euclidean geometry. However, Hilbert left between, that term, undefined and gave it some meaning with the following 4 postulates. These would be Hilbert's postulates of order. Postulate 2.1, or order postulate 1. If a point B lies between a point A and a point C, then points A, B, and C are 3 distinct points of a line, and B then also lies between C and A. So if B is between A and C, then B is also between C and A. So there's sort of a symmetry there in the order of things, right? And also notice that to be between the points A and C, B has to be on a same line with A and C. The second postulate for order of Hilbert's is, for any 2 points A and C, there always exists at least one point B on the line, the unique line containing A and C, line AC, such that C lies between A and B. This is what we would call a denseness property. No matter which 2 points that you pick, there's always another one between them. No matter how close they are, you can always squeeze at least one more point in between. That's a density property or denseness property that the real numbers have and that points on a line have. The next one, the third order postulate of Hilbert, says of any 3 points on a line, there exists no more than one that lies between the other 2, which means you can basically have an order to the points on a line. There's an inherent order there to it. And then postulate 4 of his order postulates, let A, B, and C be 3 points that do not lie on a line, and let A be a line in the plane ABC which does not meet any of the points A, B, and C. Okay, if A passes through a point of the segment line segment AB, it also passes through a point of line segment AC or through a point of line segment BC. We may come back to that one later and talk a little bit more about what that one means. But let's see, basically it's saying that if it goes through one side, basically if it goes through one side of a triangle, then it's got to go through another side of the triangle, right? Maybe at the end point, maybe at another point. So see if you can make sense of what each of these postulates is saying as they relate to your intuitive understanding of Euclidean geometry. And I've already said this about the density property. So we could use these postulates to then prove some further propositions about order. However, these proofs are somewhat difficult and they can be made easier with the introduction of a distance metric. So in a strictly synthetic approach to geometry, concepts of measurements and distances and angles are all put off as long as possible. However, the concept of measurement, including distance measures, is fundamental to the study of K-12 geometry, and it has important applications in our world. And of course, you're already somewhat familiar with that. And so because of this, we will take a hybrid approach by introducing the distance metric right now, this week, in this playlist to our study of unified geometry. And once the appropriate definitions of postulates are added, we will then be able to actually define the term between. Remember, Hilbert took it as an undefined term. We are going to actually define it. And we will then prove Hilbert's statements above, making them propositions instead of postulates. Of course, with Hilbert, they were postulates. They were accepted without proof. We're going to actually prove them. That turns them into propositions. Now, once we've proved them, from that point on, we can use them in further proofs. So we could, from that point on, proceed exactly like Hilbert did and prove following statements using his statements above, his postulates, our propositions. Or we can use the same kind of techniques that we used to prove Hilbert's postulates. We're proving them as our propositions again. We can use the same kind of techniques there, and that is going to be the use of a distance metric. So before we go any further into this, we're going to take a stop and do an informal look at distance measurements. We'll pick that up in the next video.